Hello to all of you. My name is Christian Skogen, and I'm the lead editors programmer for Total War at Creative Assembly. Today, I'll be giving a quick glance at some of our editor technologies and how we utilize Qt for them. First, a little bit of a background on Creative Assembly. We are a multi-award-winning studio formed in 1987 with more than 800 current employees across 4 studios and 2 countries. We're most known for the Total War series, as well as a few other games you might have heard of, such as Alien Isolation. Now, Total War is a strategy game series which currently boasts a total of 14 mainline titles. Traditionally, each game has focused on a period of time in history, but has since also expanded into fantasy with the Warhammer titles. It has been developed for more than 20 years and is still going strong. The main thing that sets Total War apart from many other strategy games is that it's composed of 2 distinct game modes, Campaign and Battle. In the Campaign mode, you play a turn-based grand strategy game where your goal is essentially world domination. When engaging an enemy on the campaign map in combat, you can choose to play the battle out in real time, which engages the second game mode, Battle. This is an entirely different type of gameplay experience in which you control hundreds of thousands of units to defeat the enemy in a single battle. To support these 2 game modes the best that we can, we have built a custom game engine, and with that comes the need for custom tools, which is where my team comes in. As you can see in the 2 images here, there are all sorts of different types of assets involved in both game modes. For example, terrain, models, VFX, animations, shaders, materials, and UI, to name a few. So first, a quick word about the content pipeline. This kind of thing is quite common in games development. The diagram you see on the slides at the moment is a very high-level generalization of the art pipeline for various different types of assets. Generally, things start in the concepting stages, from which raw assets are created in proprietary tools that some of you might recognize. These raw assets are often not immediately ready to be used in-game, and as such, we've created a number of tools to facilitate this part of the process. Each type of asset listed here is typically handled in its own editor. So, why Qt? As I already mentioned, we have a custom game engine written in C++. To be able to easily reuse the same type of code that we use in the game, like utility libraries and rendering, this kind of thing, we decided to also write our editors in C++. This also proved to have benefits in the performance department. Previously, we used MFC for the editor UI, but we wanted something nicer to work with, at which point we made the transition to Qt after careful deliberation. On top of being a great UI library, it comes with a plethora of extra libraries that we make extensive use of. So now that the stage has been set a little bit, let's talk about how these editors are structured. Each editor is a standalone program and is usually built to handle a specific type of asset. We make extensive use of patterns like MVC and MVVM when designing these editors. As the top diagram illustrates, an editor is often composed of 3 primary components: a model, systems, and UI. Systems and UI can access the model, but not the other way around. UI can make use of systems, but systems also cannot access the UI. And UI components can most often not access other UI components either. This ensures a stable and predictable data flow. There's also a large set of shared components for each editor to use, illustrated by the bottom diagram. So let's have a look at some of these in a bit more detail. So for the editor, the model is often composed of 2 primary things: asset data and editor runtime state. There is comparatively limited usage of Qt here. However, we do tend to use Q objects quite extensively for things like signals and events. The Qt signal system is a very convenient way to convey changes in the model to the relevant systems and views. Now, contrary to the model, the UI part obviously uses Qt very extensively. Each UI component is usually a custom Q widget, which composes other types of widgets, such as labels, buttons, views, and so on. Most of the widgets are set up programmatically or in a more data-driven way. For the widgets that are more complicated in nature, we tend to use the Qt designer to create UI files for them. Now, the systems are somewhere between the model and view in nature. Whilst there is no real Qt UI involved here, Qt is often used for non-UI things, such as multi-threading, event handling, image manipulation, and these kind of things. Now, moving on to the shared code, we have a library of smaller scale custom widgets that are used across multiple editors. Although Qt already provides a large set of UI functionality out of the box, it also makes it very easy to extend functionality. This has been instrumental in allowing us to get the UI interaction that we desire. This can either be creating new functionality or combining features of multiple already existing Qt widgets. Shortly, I'll showcase some of these widgets. Also, our editors make extensive use of the Qt view models, and sometimes these are generalized and shared across editors. So one example of this could, for example, be we have a tree model that represents the virtual file system that we use. Sometimes we are also able to abstract entire systems for use across editors. One example of this is a collection of widgets and view models that are used to interact with the entity component system that some of our editors use. I will also show some of this later. And finally, we also bundle up things like our extensions to the Qt metatype system and other things into this shared library. Now, following this high-level explanation of how we structure our editors, I would like to briefly showcase one of them in action. So, this is the animation editor. In this demo, we'll begin by loading an entity into the scene and applying an animation to it. In this case, I'm selecting an attack animation. The timeline at the bottom of the editor can be used to control playback of the animation, as well as to place metadata events. Here, I'm now using a custom widget to search for the metadata event that I want, which in this case is a VFX event. I'd like to try and spice up this animation a little bit by adding an explosion at the point of impact. So here you can see that I'm positioning the spawn position of the VFX in the 3D view. And the bottom left, I'm using another custom widget to search for the exact VFX that I like to use. We have a lot of different VFX, so being able to search for them like this is instrumental. And finally, we can play the animation back again and observe the change that I just made in action. Pretty cool. So, there are quite a few things that happen in this video. Let's talk about some of them a bit more in detail. This editor is, amongst other things, used to prepare animations for in-game use. Now, much like other editors, it comes with its own set of bespoke widgets, which mostly employ shared widgets in some way or other. Now, the main UI is just a standard Q window, and it's using the built-in Q menu, Q toolbar functionalities, and so on, as you can see in this picture. Okay, starting off, in the middle you can find the 3D view. So this is using our in-game renderer to basically render directly into a standard Q widget. We use Qt mouse and keyboard events and translate them directly into camera controls and other functionalities within the view, such as moving the 3D transform gizmo around, like you could see that I did in the video earlier. In the top left, there's the entity list widget, which is one part of the shared entity component system package that I mentioned earlier. The data comes from the entity component system, and it's transformed for the view in Qt using a simple implementation of a Q abstract item model. The widget composes a Q tree view and builds quite a bit of UI interaction on top of that, since the users need to be able to flexibly manipulate the entities in the scene. Now below that, we have the Entity Properties widget, which is also part of the aforementioned package. There's two main parts to this. One is a model based on, once again, a Q-abstract item model, which describes a two-level deep tree for components and component properties respectively. The other is an item delegate system that describes how the persistent editors in this view should look and feel. This is important here because we want live editor widgets instead of using edit triggers in the view. The widget itself is essentially just a Q-tree view, as it doesn't need much user interaction compared to the previous entity list widgets. The widget in the bottom left also uses the aforementioned delegate system for persistent widgets, but I'd like to highlight one widget in particular. What you see here is the custom searchable combo box that we have created for situations where the list of items is quite long. It inherits QComboBox and utilizes a QCompleter to aid search functionality. And for this view in particular, I'd like to lastly talk about the timeline widget. This is actually two systems, a 2D canvas and a timeline. The 2D canvas is a generic system that allows for painting and interacting with 2D shapes on what is essentially an infinite canvas. The timeline system makes use of this for rendering, and it builds timeline-specific extensions on top of it. In essence, it's just a regular Q widget for which we handle custom painting and event handling in its entirety, and the painting is handled through QPainter. The QPainter system has been incredibly convenient for this, with its large set of functionality for painting all sorts of things. Now, one of the sub-windows that popped up during the video was the battle animation editor. This is essentially a database of sorts for animations in the battle mode. The primary challenge with this one is the relatively large dataset. So again, using a custom Q-abstract item model coupled with a Q-tree view, we are able to represent this data in a user-friendly and efficient way. As you can probably tell by now, the view models and views are used very extensively within our tools, and it's a very important part of the Qt package for us. And finally, we have the little widget that popped up momentarily when adding a new animation metadata event to the timeline. This is an all-purpose widget that allows filtering through a tree of data. The animation editor specializes this widget for animation metadata use and provides a quick and intuitive way for artists to add new events. So to summarize, having an in-house game engine calls for in-house tools. Qt's played a critical part in allowing us to develop large-scale C++ editors. We use non-UI Qt components in the backend, such as QObjects for signals and event handling, SQL functionality for databases, and various data formats. Finally, our UI components make extensive use of Qt's large library of widgets, and the extendability of these widgets has been crucial in allowing us to create the exact kind of user experience that we want. And that's all from me this time. Thank you so much for listening, and I hope you found it interesting.